Okay, so section 2.11 is about graphing quadratic inequalities. So this should actually be really easy because we have already graphed quadratics. So we know what to do with a quadratic that's in standard form already. So we're just going to add the inequality symbol in here and talk about what to do if there's a less than or a greater than sign. So some steps up here at the top that you can kind of go through. Create a table of values. So I'm going to let you guys use a calculator for this. So can use calculator for this lesson. So we're going to just type this into y equals and get a table of values. Recall that the vertex should be in the middle. So we know that every time we graph and quadratic, we're going to put our vertex in the middle because the points on each side are symmetrical. Then we're going to graph it. And so there's two things that we have to do with the inequality symbol. One of them is that we have to decide whether we're going to do a dashed line or a solid line. So a dashed line if it's not equal to, and a solid line is when it is equal to. So if it's just a less than or a greater than, we use a dashed line. If it's a less than or equal to or a greater than or equal to, then we do a solid line. And the other thing that we use the symbols for is we decide whether we're going to shade inside the parabola or outside the parabola. And this says, assuming y is to the left, so if it's written in standard form with y on the left-hand side, then you can shade above for greater than or equal to. So above for greater than or greater than equal to. You're going to shade below for less than or less than or equal to. Okay. So let's look at this first example. Y is greater than x squared plus 2x minus 2. So this is a parabola. We know it's going to graph a parabola, and this is in standard form. So I know a couple things already. I know this parabola is going to open up because the a value is a 1, positive 1. And I know my y-intercept. Remember, my y-intercept is at negative 2. So I already know that point right there is definitely going to be on my parabola. So I'm going to go type this into my calculator and get my vertex and some other points on my parabola. Remember, we could do negative b over 2a and do this all out by hand. You have to be able to do that for the test. But for this, I'm letting you use your calculator. But there is a no calculator part on this next test where you will have to be able to find the vertex when we're in standard form. And so you're going to do negative b over 2a to find what this value is. So it would be negative 2 over 2. So I already know it should be at negative 1 because I just did that. But we can get our values from typing it into the calculator as well. X squared plus 2x minus 2. Right? And so look at our parabola. We know it opens up. We know it should cross right here at negative 2. It does all the things. Let's go look at our table and find our vertex. Looks like my vertex is right here at negative 1, negative 3. How do I know that? Because the points on each side of it are symmetrical. Negative 2 and 0 are both at negative 2. Negative 3 and 1 are both at 1. And 2 and negative 4 are both at 6. All right, let's graph our parabola. Let's put these points on our graph. So my vertex is at negative 1, negative 3. Negative 2, negative 2, 0, negative 2. We already knew the y-intercept from standard form. 1, 1, and negative 3, 1. And negative 4, 6. And 2, 6. Okay, now this is a greater than but not equal to. So it's going to be a dashed line. And since it's a greater than, I'm going to shade above. So my vertex is, or my parabola is going to be dashed. Okay. And when I'm looking at shading above or below, I always look at where the vertex is. Okay. So here's my vertex. Above the vertex here would be inside, and below the vertex would have been outside the parabola. So that's what I kind of look at. I look at where my vertex is to decide above and below. If you're confused on deciding above or below, you can always pick a test point. So pick a point that's either inside or outside the parabola, but not on the parabola. You don't want to pick a point that's in your table of values. And just test it and see if you get a true statement or not where that point is. So I like to test 0, 0 because it's really easy to test. 0, 0 would be inside where my shading is, which means I should get a true statement if I plug 0, 0 in here. So if I do that, if I plug in 0, 0, I'm going to get 0 is greater than 0 plus 0 minus 2. 0 is greater than negative 2. That's true. Therefore, I need to shade where 0, 0 is, and I did that, so that's what I get. All right, let's do another one. This one is y is less than or equal to negative x squared plus 4x minus 1. So for this one, I know my, it's going to open down, and I know that my y-intercept is at negative 1. So let's get some other points. If I wanted to find my vertex by hand, I do negative 4 over 2 times negative 1. And so we could figure that out. We're just going to go, I told you guys you could do these in the calculator. So be sure when you type in this negative x squared, you use the negative at the bottom. Don't use the subtraction. When you do negative in the front, you have to use the negative. So negative x squared plus 4x, and now it is subtraction, so minus 1. So here's my parabola. I know it opens down, and I know my y-intercept is at negative 1. So let's go to our table of values. Looks like my vertex is right here at 2, 3. So then the points on each side of that, so 1 and 3 are both at 2. 4 and 0 are both at negative 1. 5 and negative 1 are at negative 6. Okay, let's graph all these points. I'm going to start with my vertex so I can see my symmetrical points on each side. Over 2, up 3. Then over 1, up 2, over 3, up 2. Those are symmetrical. 0, negative 1, I already have that one on there. And 4, negative 1. 5, negative 6. 1, 2, 3, 4, 5, 6. And negative 1, negative 6. And okay, so this is a less than or equal to. So this is a solid line. And it's a less than, okay, because it's pointing the other direction. So it's a less than. So that means I'm going to shade below. So here's my solid lined parabola. And since it's a less than, remember, I like to go to where the vertex is, and less than would be inside. If it was a greater than, that's greater than the vertex would be up here, and you would shade all this outside area. So my solution region is all the stuff inside the parabola where I just shaded. Again, if you want to test a point, you can. You can test 0, 0. You should get that it's not true because 0, 0 is not inside my shaded region. If you want to test a point, you can. Otherwise, you can just use the above and below. All right, let's look at number 3. Y is greater than or equal to negative 3x squared plus 18x minus 22. My y-intercept on this one is down at negative 22, so I'm not going to graph that one. I also know this parabola is going to open upside down, negative 3, and it's going to be skinny because it has a vertical stretch of 3. So let's go type this into our y equals and get our vertex and some information. Negative 3x squared plus 18x minus 22. All right, here's what our parabola looks like. So it's doing like we said it would. It's going to open upside down. So I'm going to go to second table. So here's my vertex. I can see it. It's going to be right there at 3, 5. I could do negative b over 2a and have gotten that as well. So 3, 5. So symmetrical points on each side. 2 and 4 are at 2. 1 and 5 are both at negative 7. 0 and 6 are both at negative 22, which we already knew that. I've got them in my table, but I'm not going to put them on my graph. Okay, 3, 5. 2, 2, 4, 2, and 1, negative 7, and 5, -7. And all right, so that's good. I can see it's skinny because it has a vertical stretch. So let's go ahead and let's see. This is an equal to, so that means a solid line. So I can do my solid parabola. And then it's a greater than, because alligator eats the bigger one, chomp, chomp. So it's eating this side, so it's greater than. So I'm going to shade above. Here's my vertex. Above the vertex is outside the parabola. So that's where I'm going to shade. So that's my solution region. All right, let's look at number 4. Ooh, number 4, I can say is in standard form, or it could also be vertex form. Remember with this guy, vertex form is HK. So my H value, there isn't one because there's nothing inside the parentheses being added or subtracted from the X. And then my K is a 6. So I already know my vertex is 0, 6 on this one, which is also my Y-intercept. So I've already got information here. 1, 2, 3, 4, 5, 6. And this parabola opens up, so I must be going up here somewhere. So I can use my calculator to find some more points real quick. X squared plus 6. There's my parabola. It's opening up. My vertex is at 0, 6. My vertex and my y-intercept are the same coordinate this time. Let's go to our table. I already know my vertex. It's right here. So I can see the points on each side of it are symmetrical. So let's put them in our table and draw our parabola. So -1 and 1 are both at 7. 2 and -2 are both at 10. And I'm not going to put 3 and -3 on my graph because it goes up to 15, but that's okay. So -1 and 1 are at 7. -2, this is 8, 9, 10. And 2 is at 10. So close enough. All right, this is not equal to, so it's going to be dashed. So I'm going to dash my parabola when I draw it. And it's a less than, so I shade below. So here's my vertex. Below my vertex is outside this parabola. So all this other stuff is my solution region. All right, I want you guys to try these two on your own and look at my completed notes. So go ahead and do these two, please, and look at the completed version of my notes and make sure you got them right. All right, in the meantime, let's flip over and do one of these quadratic inequality real world examples together. All right, so this is talking about a rope, and we have a rope, and we're going to use it to rappel down a cliff. So it says a manila rope used for rappelling down a cliff can safely support a weight in pounds of, okay, and this is the weight has to be less than or equal to 1,480 d squared, where d is the rope's diameter in inches. Okay, so the diameter is like how wide around the rope is, how narrow or how fat the rope is. And we're going to graph the inequality and show the weights that would be safe to use the rope or the weights that would not. Okay. So if I go to plug this in my calculator, I'm going to have to change my window settings around a lot because I know that 1,480 is not just going to show up in a standard 10 by 10 window. But let's try to maybe just do this without for a minute and see what we can get to happen. So this is like our y is less than or equal to 1480x squared. So I'm going to do like if I did x like this and y, except my x is actually my d and my y is actually my w. So on my x-axis, this is going to be my diameter of the rope in inches. And my y-axis is going to be the weight that it can hold, and that's in pounds. And so let's try to figure some stuff out here. What if I don't have a rope at all? No diameter. So 0 squared times 1480 is 0. Okay. Well, what if the rope's diameter is 1 inch? So we've got a 1 inch rope. Okay. So the rope's diameter, although the length across is 1 inch. 1 squared is 1 times 1480 is 1,480. So a 1 inch in diameter rope can hold 1,480 pounds. That's a lot. What if it's 2 inches? Okay, well, we can just do some math here. We can do 1,480 times 2 squared, 1,480 times 3 squared, 1,480 times 4 squared, and I'm getting all these values for what this would be. I can also do this if I put this in y equals, I can go generate my table and it would do the same thing. So 2 squared, I'm at 5,920 pounds. 3, if the rope's diameter is 3 inches, it can hold 13,320 pounds. 4 is 23,680 pounds. 5 is 37,000 pounds. 6 would be 53,280 pounds. And I'll put one more 7, 72,520 pounds. That's a lot. Okay. So my x-axis, when I go to graph this thing, I'm just going like 0, 1, 2, 3, 4, 5, 6, 7. So I'll just do it by ones. No problem. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. That's the rope's diameter in inches. But my weight, I need to go from like 0 to, man, this goes up to 72,000 pounds. So I can't do them by thousands because I really only have 1, 2, 3, 4, 5, 6, 7, 8. Looks like about 20 marks. So thousands would only get me up to 20,000. What if I go by 5,000s? Does that help me? I think that would get me maybe to where I wanted to be. So if this is 5,000, this is 10,000. 15, 20,000. 25, 30,000. And then 40,000. 50. 60,000 and 70,000 would be here and 80,000 would be here. Okay, so let's graph these points now. 0, 0, 1, and 1480. So if this is 5,000, so 1,480 is just going to be a little bit up. 2 is at 5,920, so this is 5,000, so I'm just going to go right above there. 3 would be 13,000. So let's see, this is 10, this is 15, so 13 would be about right here. 4, I'm at 23,000. So if this one's 20, 23 would be about right here. 5, I'm at 37,000. So here's 35, 37 would be almost to 40. 6, I'm up at 53,000. So here's 50, 53, because I'm not quite to 55. 7, I'm all the way up here at 72,000. So not quite to 75. And we can see it's forming a parabola. And it's equal to, less than or equal to. So it's going to be a solid line. Okay, so I only worry about the positives here because I'm not going to have a negative diameter on my rope. Okay. And then it's less than, which means I'm going to shade below. So here's my vertex. So I would shade below, which means I'm going to shade all this. So these are this is the diameter and the weights that the rope would hold. So an 8-inch diameter rope would hold a lot of weight, right? Because it would be any of these weights out here. But for example, a 2-inch diameter rope, if you try to put 20,000 pounds on a 2-inch diameter rope, it's not going to hold because that's not in my shaded region. Okay. So that's kind of what we're looking at with these real world examples like this, is it gives us like you can test something out to see if it actually works or not. So, all right, I want you guys to kind of look at this one and try it on your own. I'm going to do this out for you. The completed notes will be done for you. So this one's a little bit more confusing, but it's really just kind of typing it in and seeing what's happening with the numbers to figure out the years. So try that one on your own, and I know you guys got this.